Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new video in data modeling that are star schema, snowflake schema and galaxy schema. All these type of schemas we will be watching in this particular video in detail. So let's get started with the video. Before moving ahead with these schemas, let me recap the things which I covered up in the previous video so that it will be relatable when I will move forward with these. So first one is dimensional data modeling. So dimensional data modeling, if you are aware, if you are not, then you can go and check out that video. So into that which I have covered up, it is just a method to organize and structure your data in the optimized way. So that if you want to have query and analysis or reporting over that particular database or data set, you can go ahead with that reporting or analysis, anything. After that, we have covered up that there were two types of table in dimensional data modeling, that those were fact table and dimension table. Fact table was the primary table, or you may say in layman term it's a summary table in which you are maintaining the summary of whole your data set. In dimension table, we are keeping the more detailed information about any particular type of data. The example which I have showed you that day, it was suppose this is the fact table, which is the sales table, and then into that sales fact table we are having multiple dimensions table like time, store, after that promotion, everything I have already explained this up. You can go and check that one. After that, into this dimensional data modeling, there were several steps involved to create the dimensional data modeling. The last step was to build a schema. So there were three type of schema: star schema, snowflake schema and galaxy schema. Today we will be moving ahead with these three. So let me go into the presentation mode. So here this star schema, first one is, it is nothing but when you organize your fact table and the dimension table into star type of visual appearance, that is only called a star schema. By linguistic definition, you can see that it consists of central fact table connected to multiple dimensional table, radiating outward, forming like a star like shape. That's it. The star schema is optimized for querying large data sets. Of course, that's why it's a very famous schema getting used into the data warehousing concepts. And after that, we are having a star schema which is into the denormalized format. So there are three schemas which we are going to talk today. So first one, the star schema, which is denormalized. Another one, the snowflake schema, which is going to be normalized into the normalized one, and galaxy schema as well as into the normalized one. So now question comes, what is denormalized and normalized thing, right? So denormalization is nothing but if suppose you are having some data, if you are having some data and that data you are keeping it twice or thrice just for the query optimization or just for the efficiency purpose, that means it is leading you to the data redundancy, in which it is nothing but data duplication. So your data is getting duplicated over there, which is only called the denormalization of the data. So in a star schema, duplicacy is more compared to a snowflake schema and the galaxy schema. So this star schema, how does it look like? It look like something like this, that your fact table will be into the middle. After that, all the dimensions table will be into each of the, you may say, corners of the fact table, in which it is just a general purpose diagram right now. Here I'm going with ahead with the one example. So this example, you can see here that it is a sales dimension, which is you can say it's a sales fact table, you may say. Into that six sales fact table, you are having customer dimension, product dimension, then company dimension. Now this fact and dimension table, it is a very frequent question, and it's a concept that how even it is getting mapped with each other. That suppose this fact table is the centralized one and dimension tables are the tables which are already, you can say that it's a detailed table, then how it is even getting mapped, that fact table to the dimension table? It's a, again, I already explained that one-to-one relationship, one-to-many relationship. There are multiple relationships we are having. So you can go ahead with that checking out the video in which I have covered up all these type of relationships. So this relationship, it is getting established between this fact and dimension table. So so that we can retrieve the data or we can map the data. Now this is how the star schema look like, and this is all about the star schema. After that, going ahead with the Snowflake schema, it's nothing but only the extension of star schema. If suppose in the previous slide we have seen that we were having fact table and dimension table, now we will go ahead with and we will go one step ahead, that is after that dimension table we will be having sub dimension table as well. That means if suppose you are having some dimension table as suppose a time dimension, in that time dimension definitely there will be a month dimension also, and it can be a quarter dimension also. We can categorize all these dimensions into another sub dimensions, correct? So that our query performance will again become more faster. So for that we are having this Snowflake schema. And why it is named so, don't go over the name, because this Snowflake schema is just an arbitrary name. It has been kept since this schema looks like a snowflake, that's why it is kept as the name as the Snowflake schema. It is something looking like this, that your fact table will be into the center, dimensions table will be on the corner of each of the fact table, as into the star schema. After that only one addition is over there, that is sub dimensions is also getting mapped with the dimension table, again with that relationship concept which I already covered. After you can see this example, that the example of this Snowflake schema, it shows you that this is suppose the sales table into which there is the dimension table as dealer, dimension table as the branch, and then date. All these dimensions table are there, and again beyond that dimension table we are having the sub dimension table. Suppose this is the dealer dimension, right? So at what location the dealer it is, what is the location ID, what is the region ID, all these things. After that this dealer is from which country, what is the country ID, what is the country name, all these things. So this is how this dimension is getting bifurcated on the sub dimension level. So this is what our Snowflake schema is. And the previous one star schema was denormalized one, and this is into the normalized format. That means you can see that it is having less data duplicacy, you may say. Now moving ahead with the last one, that is galaxy schema, which is also known as the constellation schema, is a combination of multiple star schema. That means the root thing we are having is the star schema on itself. Snowflake schema was also the extension of a star schema, and this galaxy schema is also the extension of your star schema. That means here multiple star schema, when will be combined, it will be giving you this galaxy schema, which provides flexibility and scalability of the complex data warehousing scenarios. Wherever you will be having multiple and you will be having a very complex data, you may say database design, there we will be implementing that galaxy schema. Now how does it look like? It look like something like this. That fact table will be in the between, multiple dimensions table will be correlated to fact table, and then this another fact table will be again mapped to it. It will be like a chain of star schema. Now one example I have taken over here, that is this one, that if you suppose you are having the fact table like revenue. Now in revenue you are having dealer ID, model ID, branch ID, and all these things. Again this revenue is having dimension table as branch dimension and then date dimension. Now this date dimension is again for the dimension table for the product dimension. So what this product, some product should be into some branch, right? So it this will again be mapped to the branch, and then this will be the product when it will be, it is getting manufactured, or when it is getting going to be expired. All these dates uh, detail are getting taken care in this dimension table. Now again this product table is having the product dimension as well, into which all the detail level of the product will be there. So this is how whole galaxy schema is. And when we talk on the cost level, so of course this galaxy schema is the more complex one. So it is going to be a very, you may say, a costlier solution for any of the data modeling. After that we are on top of that we will be having this less costly, we will be having the Snowflake schema, and the most less costly will be the star schema. So like this, and both of this Snowflake and the Galaxy schema will be into the normalized format, and that means data will not be that much duplicated, but into your star schema data will be the duplication will be there, which is in technical term called as data redundancy. So that was whole about these all three type of the schema. I hope that it was very much helpful to you to get the clear conception between all these three. And if any confusion, let me know into the comment section. Thank you so much guys for watching the videos. I will be coming up with another videos on data modeling. Thank you so much once again for the watching the video.